And yet it has been remodeled, refaced with granite. There are granite blocks that are placed on top of the core limestone blocks. And those core limestone blocks were already eroded when the granite blocks were put there. Why? Because the granite blocks have actually been purposefully and deliberately cut to fit into the erosion marks on the, we believe, much older megalithic blocks there.
Graham Hancock has just announced physical evidence revealing how the ancient Egyptians actually cut granite, directly challenging leading experts, shattering the long-held myth of copper saws and manual labor. His evidence points specifically to Corundum, an ultra-hard industrial abrasive still found on ancient cut surfaces. However, the academic community has immediately dismissed this discovery for a very clear reason. Corundum is not merely a tool. Its presence implies a sophisticated materials science and an international trade network, industrial systems that are absolutely not supposed to exist in the Bronze Age. This finding does not fill a gap in history. It threatens to bring down the entire existing framework of knowledge. The surface of perfection. The engineering challenge confronting the ancient Egyptians was anything but simple. Granite, a crystalline igneous rock, achieves near absolute hardness on the mineral scale. It yields only to precious gems such as topaz or diamond. Shaping this material on a scale of hundreds of tons presented an extreme test even for contemporary technology. Faced with this reality, Orthodox Egyptology has proposed a thoroughly reasonable explanation requiring no mysterious technology whatsoever. According to this account, stone cutting was performed with copper blades and drills combined with a vital element of moist quartz sand. In theory, copper is softer than granite. Yet when quartz sand possessing equal hardness is continuously scattered into the incision, it serves as microscopic saw teeth, gradually wearing down the stone mass. This narrative paints a portrait of a civilization that transformed sheer persistence into technology itself. It accounts for those grand wonders not through the lens of technical breakthrough, but through the power of determination and social organization. This explanation has become the foundation of a truth taught broadly because it is logical, practical, and fits neatly into our model of a Bronze Age world. It renders the mystery comprehensible. Nevertheless, when one examines closely the granite surfaces lying deep within the king's chamber, their absolute stillness and flawless flatness appear to belong to an entirely different process, one bearing no trace of crude manual abrasion. The contradiction between the manual procedure and perfect outcome grows evident when modern measurement instruments come into play. When a straight edge of tool steel is positioned against the inner surface of the granite sarcophagus in the king's chamber, a powerful beam of light exposes a baffling physical reality. The light could scarcely pass through any gap across a length exceeding 2 meters. This flatness attains tolerances measured in thousandths of an inch, a level of precision not resulting from manual chipping and carving, but characteristic of surfaces produced by machines operating at high speed. The anomaly becomes even more pronounced on the discarded granite drill cores. When magnified, the surface of these reveals parallel spiral grooves running parallel in a striking manner. In the principles of machining, the distance between these grooves is known as the feed rate. That is the depth the cutting tool penetrates into the material after each revolution. Technical measurements indicate that the feed rate on certain ancient Egyptian drill cores exceeds by hundreds of times the rate that a copper drill bit combined with quartz sand could possibly achieve. For a tool to carve deep grooves into hard quartz at that rate, it demands an enormous pressing force and an unimaginably stable rotation speed far surpassing human capability. These physical data are no longer speculation. They stand as technical fingerprints imprinted upon the stone, proving that the tale of copper saws and abrasive sand, no matter how reasonable, has missed the most crucial part. Shattering. It reveals that some factor intervened in the procedure, a factor allowing the ancients to attain results of a mechanical nature. And it is precisely this physical gap that has compelled researchers such as Hancock to seek an alternative explanation. Forensic material analysis. When mechanical measurements at the macro level could not provide a satisfactory answer for the cutting speed and extraordinary flatness of granite, the investigation had to advance into a smaller realm, the micro level. If copper tools and quartz sand were truly responsible for these wonders, then their traces must have left a distinctive fingerprint on the stone surface. To confirm or refute this assumption, a procedure for forensic material analysis was established, submitting samples of ancient granite to the controlled environment of modern materials science laboratories. This journey commenced with the collection of minuscule samples from unfinished cuts and core drill holes at the Giza Plateau. These represent the most pristine crime scene records, where the technical procedure of the ancients halted abruptly, preserving exactly what had truly touched the stone blocks some 4,500 years ago. Materials scientists led by experts in tribology, the study of friction wear, and surface interactions employed the scanning electron microscope. This device does not use light, but beams of electrons to generate images with magnification reaching tens of thousands of times, permitting visibility of each shattered crystal structure and foreign material particles trapped in the microscopic fissures of the granite. In the sterile space of the laboratory, tension mounted as the electron beams swept across the sample surface. Black and white images emerged on the screen, exposing a chaotic scene at the molecular level. The researchers found not only quartz or feldspar, the natural components of granite. They began to detect mineral grains with sharp angular shapes, compressed tightly, and embedded deeply into the stone surface under extreme pressure. To identify these grains, they utilized energy-dispersive X-ray spectroscopy. This technique allows firing an X-ray beam into the substance and analyzing the emitted signals to determine precisely the chemical composition of each individual atom. Initial results produced a puzzling silence within the research team. The peaks on the chart displayed on screen did not correspond to the composition of desert sand or common sedimentary rocks in Egypt. They indicated the presence of an unexpected compound, a material that, in theory, should not appear in a Bronze Age manual procedure. These mineral grains possessed a geometric and chemical property suggesting deliberate selection of a material refined and introduced into the cut with a specific objective. The investigation at this point was no longer about confirming the quartz sand story. It had reached a new boundary where an alien material challenged the entire framework of knowledge regarding ancient tools. These tiny particles of matter served as the key unlocking a technical reality long obscured by the simplification of history. Industrial material beyond reach. The moment the scientists identified the true identity of the mysterious mineral grains generated a genuine shock to the foundations of Egyptology. It was corundum, an aluminum oxide crystal, the natural mineral form of ruby and sapphire. On the Mohs hardness scale, corundum reaches level 9. To grasp the weight of this figure, recall that quartz, the main component of sand, attains only level 7, and granite sits at a comparable level. In the physics of abrasion, to cut a material efficiently and precisely, the abrasive must be significantly harder than the target material. Employing quartz sand to cut granite resembles using a stone of the same type to grind another slow and imprecise. But corundum tells an entirely different story. With its superior hardness, it transforms the stone cutting process from manual erosion into genuine mechanical assault. This discovery by Hancock and his associates immediately shattered the assumption of infinite patience. Traces of corundum clinging to the ancient cut surfaces proved that the Egyptians did not merely use sand. They employed the second hardest material on the planet, ranking only behind diamond. To verify this capability, experimental archaeological tests were conducted for comparison. When modern stonemasons used copper saws with quartz sand, the cutting speed reached only about 0.5 millimeter per hour, and the copper blades wore away rapidly. But when a small quantity of corundum powder was mixed into the abrasive slurry, the cutting speed surged 6-fold. More importantly, the smoothness and precision of the cut began to match perfectly with what is observed on the ancient relics. The spiral grooves on the drill cores, which had been a mystery regarding speed, now found resolution corundum permitted the drill bit to advance deeply into hard stone with a pressure and speed that quartz sand could never achieve. Nevertheless, the emergence of corundum does not represent a tidy solution to close the mystery. On the contrary, it opens a far greater contradiction regarding geography and history. Egypt possesses no natural corundum deposits suitable for industrial production. The nearest source lies on the islands of Greece, or deep within the Indian subcontinent. Discovering corundum embedded on granite blocks from the Old Kingdom era means the ancients had to establish a complex industrial procedure, from identifying the mineral based on its hardness to extracting it from distant locations, transporting it across continents, then crushing and sorting it into optimal particle sizes for workshop use. This was no accidental craft trick. It constitutes evidence of applied materials, science operating at large scale, a reality impossible to explain within any conventional framework of the Bronze Age known to us. The presence of corundum serves as material proof of an overlooked technological reality, something experts would rather deny than confront the profound implications it carries. The domino effect of a single trace. Once we accept the existence of an abrasion process based on corundum, the entire picture of ancient Egypt begins to reverse completely. This is the moment when perception is thrust into a zone of instability, for corundum cannot exist as an isolated fragment. Throughout human history, technology has never appeared as separate islands. It has always emerged from a complex ecosystem of knowledge and infrastructure. Acknowledging that the ancient Egyptians operated a sophisticated abrasion industry triggers a domino effect, compelling us to reevaluate every aspect of that society. First come the consequences for trade and economy. If corundum was not locally available, then possessing it in large quantities to construct multiple pyramids and temples would have required a strategic international supply network. We often imagine ancient commerce as the exchange of luxury goods, such as gold, frankincense, or silk. Yet this discovery points to an entirely different kind of industrial material trade. It suggests that 4,500 years ago, there already existed dedicated mining agreements and specialized transport routes serving solely the technical demands of hard stone construction. A purely agricultural society could not sustain such a network. It demanded an advanced economic management system and an industrial vision that we have never before attributed to the ancients. Next come the consequences for scientific knowledge. The selection of corundum demonstrates a profound understanding of the physical properties of matter. To create an effective abrasive slurry, the ancients needed not only to identify the hardest stone, but also to master its processing. Corundum powder had to be ground to a precise degree of fineness. Too coarse, and it would damage the stone's surface. Too fine, and it would lose its cutting power. This proves that the Egyptians possessed an experimental scientific tradition in which mineralogical knowledge was systematically organized and passed down through generations of specialists. It represents a leap in awareness that the ancients did not work through blind instinct or endless patience. They operated according to applied scientific principles. This upheaval is truly dangerous because it blurs the boundary between ancient and modern. It shows that the sophistication of a civilization need not be measured by whether it possessed electricity or computers, but by its ability to solve the most complex physical problems through superior practical knowledge. If we have completely overlooked an industrial system based on corundum for more than a century, then the model of a primitive Egypt that we have long accepted is in reality little more than a veil concealing a far more intricate reality. Corundum is not merely a stone-cutting tool. It serves as a thread slowly unraveling the entire historical tapestry woven from outdated assumptions. The wall of consensus. When Graham Hancock presented evidence of corundum at scientific conferences, he encountered far more than questions about the data. He collided with an invisible wall of systematic resistance. The reaction from a large segment of Orthodox Egyptology was not one of scientific curiosity toward a new discovery, but a sharp defensive rejection. This resistance reveals a troubling truth about how truth itself is protected within academia. Sometimes the stability of an established knowledge system matters more than the evidence itself. The reasons behind this response are not difficult to understand. If experts were to acknowledge the existence of sophisticated materials, science in ancient Egypt, thousands of textbooks would become obsolete. Hundreds of doctoral theses would lose their foundation, and the credibility of an entire educational system would come under threat. The presence of Corundum and its industrial implications represents an anomaly that cannot be tolerated within the current framework of understanding. Therefore, instead of examining the images from the scanning electron microscope or the results of X-ray spectroscopy, the Orthodox community frequently resorts to gatekeeping. They focus on questioning the credentials of those presenting the evidence, rather than confronting the undeniable physical data imprinted upon the stone. This silence and obstruction create a heavy psychological pressure upon anyone who dares step beyond the permitted boundaries. Reports of cuts that cannot be explained are routinely ignored or labeled as conspiracy theories, even when supported by precise physical and chemical analyses. The fear does not stem from any specific authority, but from the very structure of the knowledge system itself. A system that refuses to allow any data to undermine the assumption that human progress moves in a straight line from primitive to modern. Acknowledging that the ancients may have reached a peak in materials technology only to lose it afterward is an idea considered far too dangerous. It implies that our own modern civilization could suffer the same fate. This resistance is ultimately a limitation of perception. It shows that we tend to see only what we have been trained to see. When an archaeologist looks at a piece of dolerite, they automatically assume it is a hammer. When they encounter corundum, they dismiss it as later contamination. The physical evidence of a different past has always been present on every centimeter of granite at Giza, yet it is nullified by a collective consensus that refuses to permit its existence. This is the point where the investigation ceases to be about ancient technology and becomes instead a confrontation between physical proof and the conservatism of the system. We now stand before a boundary where truth is not only buried beneath sand and dust, but also beneath the deliberate silence of those who control the power of knowledge. The torn-out chapters of history, the investigation into granite, and the traces of corundum has ultimately led us back to the greatest question of all. If the ancients truly operated such a sophisticated industry, why do we know nothing about it? The answer may not lie in some grand conspiracy of concealment, but in a simpler and colder reality. We have underestimated the intelligence of our ancestors based on the arrogance of a civilization that possesses electricity and computers. We have patched over vast gaps in our knowledge of Egypt with assumptions about primitive tools simply because we could not imagine any path of development other than the one we ourselves have followed. The discovery by Graham Hancock regarding corundum is not the final answer, but rather a fundamental reshaping of perception. It demonstrates that human history is not a steady line of evolution, but a book with many chapters that have been torn out. The microscopic traces upon the granite blocks represent the final remnants of one such chapter. A chapter about a brilliant materials science that once existed, reaching its peak in the conquest of the hardest substances on the planet, only to vanish almost completely, leaving behind wonders that we still struggle to explain. We have long viewed the Egyptians as patient craftsmen, but the evidence now shows they were genuine materials scientists. The truth about how they cut granite has finally emerged not through magic, but through knowledge. They harnessed the power of minerals and the principles of physics to master nature. Yet understanding the method is only the first step. The real consequence lies in the realization that we are viewing the past through an extremely narrow opening. If an entire abrasive industry could be completely forgotten, then how many other sophisticated systems of knowledge concerning chemistry, engineering, or energy have had their traces erased simply because we lacked the humility to search for them? The video concludes with an image of the silent granite blocks at Giza beneath the night sky. They are no longer soulless stones, but containers of information waiting to be read correctly. The explanation offered by Hancock does not bring comfort because it forces us to acknowledge that the picture of humanity we have held for so long is distorted and gravely incomplete. We are not confronting an alien mystery or a supernatural civilization. We face a far more unsettling possibility that human beings thousands of years ago once possessed great knowledge that we today can perceive only through microscopic traces upon stone. We understand that we have been wrong, but we do not yet know how much more we have missed. True history does not reside in textbooks. It lies within those very granite blocks, quietly awaiting a generation courageous enough to look beyond the wall of consensus and accept what has been present before our eyes all along.